This video is going to cover Unit 25, Section 5, Circle Postulates. First one is on the bottom of page 622, and it says that all radii of the same circle or of congruent circles are equal. Congruent just means that they're the same dimensions. So all of those radii are the same. The one at the top of page 623 says, a diameter bisects a circle and the surface area. But at the same time it says that if a chord bisects the circle, then it is a diameter. So they prove each other. The next one says the diameter of a circle is the longest chord of the circle. Because remember, a chord, or a diameter rather, is a chord. It's also the longest chord. And then the next one says that a straight line passing through a point within a circle intersects the circle at 2 and only 2 points. So let's take a look at what that's talking about exactly. So let's get a circle here. And let's find a point within. Now we're talking about a point within the circle, like that one right there. Okay, we'll call it point K. All right. Now we're not talking about a point that would be right on the circumference, because that would be a tangent line. So if I have a point inside the circle and a line intersects that point, then that line will intersect the circle at 2 points, here and here. That's what that's talking about. Now the next one says, in the same circle or congruent circle, equal chords subtend or cut off equal arcs. So let's take a look at the bottom of page 623. It's just easier to do this than to try to draw that. Okay, so what this is talking about is the chords first. If chord EF, chord CD, chord MS, and chord GH are all equal, then that means that arc EF, arc CD, arc MS, and arc GH are equal as well. That's what that's talking about. All right. So the next one starts at the bottom of page 623 and finishes at the top of page 624. And that says that in the same or congruent circles, you have central angles. They will subtend the same arc length. So let's take a look at what they're talking about there. All right. So there's a circle. Central, draw that right there. And if I have that right there, so we'll call this, I don't know, what do they call it? They call it AB and GF. So if this is angle 1 and this is angle 2, and these are central angles, okay? So these angles are going to equal each other. So if angle 1 is equal to angle 2, then that means that arc AB is equal to arc GF. That's what that one's talking about. Now, the next one, this is the big one. We're talking about central angles with this one as well. In the same circle, two central angles have the same ratio. So let's make the two central angles. Now these central angles are not equal. These ones were, these ones are not. Okay, one of them is 75 degrees, the other one is 42 degrees. And then we have this arc length here, CD, is 18 inches. And we do not know what this arc length down here is, EF. All right? However, let's look at the postulate. Well, say that 10 times. In the same circle, two central angles have the same ratio as the arcs that subtend them. So that means that this angle and this angle have the same ratio as this arc and this one. So I can write that like this. 75 divided by 42 is equal to, and 18 is related to the 75. So I'll put 18 right there. And then arc EF is what we're looking for. So 75 times arc EF is equal to 18 times 42. So we divide this by 75, makes that a 1. We divide this by 75. So in the calculator, fraction bar, 18 times 42 in the numerator, 75 in the denominator, and that is equal to 10.08. So EF is equal to 10.08. All right. Now, with the next postulate, it says a diameter perpendicular to a chord bisects the chord and the arcs subtended by the chord. And the chord passes through the center of the circle. Let's take a look at what in the world we're talking about here. Can I get that? Under here. Yep. All right, so here we have that situation. A diameter, which is DE, is perpendicular to chord AB. So if that's true, then it cuts AB in half. It bisects it. So that means that AC is equal to CB. It also means that the arc AD is equal to the arc DB. And also at the same time, this way, arc AE is equal to arc EB. Okay, that's because the diameter is perpendicular to that chord. All right, ta-da. Sometimes it's better just to look at it rather than to draw it. All right, so let's take a look at some of these problems here. On page 627, let's see if any of these are any good. Remember, never say Okay, so let's take a look at number 9. I might have gotten in over my head with that one, right? central angle, something like that. Ta-da! E F P 146 82. All right. So part A says, what is edit. Part A says, what is HP, arc HP, when arc EF, right here, is 20 or 2.8, almost too far for me to see it. Okay, so that means that I have 146 over 82. Let me try that again. 146 over 82 is equal to, so EF is with here, with the 82 degrees, and that is 2.8 inches. So what is this one right here? We'll just call it X for right now. I don't like to use two letters. And now, so 82X is equal to 2.8 times 146. So this is my numerator, so 2.8 times 146 . 408.8. Now I'm going to divide that by 82, and I get, it rounds to 5. So X is equal to 5. So that means that arc HP equals 5 inches.